Today we are doing 4.1. We're starting Unit 4. This is all going to be on rational functions. We're going to be graphing the rational functions. We just finished a unit on polynomials, okay? So we're switching to rational. Before we get to some of the stuff, the graphing and all that, we need to review some of these rules. So we're going to review how to simplify a rational expression, and then we're also going to multiply and divide. Rational expressions. You'll notice that in rational, you have the word ratio, and a ratio will look like a fraction, right? So these are going to be things that have fractions in them. And we just need to review all the rules, and you need to know that the rules are the same whether there's letters in there or not. It's the same rules, okay? To begin with, the rational expressions that we are going to be dealing with predominantly, every now and then we'll mix this up just a little bit, but predominantly our rational expressions are going to be a polynomial divided by a polynomial. So what we were dealing with in the last unit over the same thing, well, or over a polynomial, okay? Every now and then we'll throw in something different like an absolute value, but that's going to be the exception for this unit. Or typically we have a numerator over a denominator, right? A ratio. Okay, so going back to what, maybe 5th grade? Do you think that's when you guys first did fractions? Maybe even before that? When you were simplifying to begin with, and we're going to then apply this to throwing in letters, okay? But if you're simplifying something like 10 over 25, obviously you've done this so many times now that you could just look at that and tell me the answer to that is what? What does that reduce to? 2/5. What did you do? What'd you do? Divided by 5. Both of those terms we divided by 5. Okay. When you first learned this, you may have learned this by factoring. I don't know, or maybe you just looked at what was the greatest common factor. But this is the idea. This is the concept. 10 is 2 times 5, and 25 is 5 times 5. And since they both share a factor of 5, you can reduce. And reducing, you guys, is dividing. It is dividing. Keep that in mind when you're trying to figure out what should be left. Okay? But we can divide by 5, which we say reduce. Sometimes we'll say cancel, right? And you're left with the 2/5. Notice that everything was multiplied. It has to be multiplied to be able to cancel, okay? This, 2 plus 3 over 2 plus 5. The minute we throw letters in, people want to cancel those, the 2's like that. They want to cancel the 2's. You can't do that. Because 2 plus 3, really you'd add the top, you'd get 5 over 7. If I cancel a 2 out of this, is that equal? Is 3/5 the same as 5/7? Obviously not, right? You can't cancel that, okay? Here's what how you want to approach these. If you have a plus or a minus, you need to view that as tying those two terms together. And you either have to be able to cancel the entire thing, okay, or you can't cancel it. So the minute we throw in letters then, like x plus 3 over x plus 5, you can't cancel those x's. As much as you'd want to, you can't do it, okay? Because you're not going to get the right answer if you do. You're not following the rules. It has to be factors that are multiplied that you can cancel. Now, if I had an x plus 3 times x plus 2 and then x plus 3 in the denominator and I could cancel the whole thing, that's legal, okay? But you have to be able to cancel the whole part here, the x and the 3 tied together by that plus sign. Got to be able to cancel the whole thing, okay? So again, an example, say I had 2 times x plus 2 over 3 times x plus 2. This is where you can cancel, and it's that entire, you're going to divide both the top and the bottom by the common factor of x plus 2. Notice it's multiplied. You can have a plus sign as long as it's inside the parentheses. That's okay, but not outside. Outside, no parentheses here. And even if I put parentheses around that, I wouldn't cancel that because they're not the same. But here I can reduce that, and the answer to this would be 2/3. Okay, so again, just making it really, really clear, it has to be factored, and then you have to cancel the entire factor, not just part of it. You got to cancel the whole thing. Okay? All right, so what we're going to be doing first, the examples here, the directions are going to be to simplify, and for the first part of this worksheet, it's going to ask you to also state the excluded values. And for those excluded values, those are going to be, for this portion of this exercise, any value that at any point makes the denominator equal 0. Okay, we're going to exclude from the beginning, any point in between, the end, any place where the denominator would be 0, we need to exclude it. Okay, so for example here, number 1, 21a squared over 3a cubed. Okay, just for this first one, we're going to write this out the long way. I do not want you writing this out the long way on all this assignment. Okay, I don't want you doing it this way, but I want you to see that what we're doing is the same as what we did up here. Okay. If I multiplied, if I factored 21, I'd get 3 times 7. And really, a squared is a times a, right? And then down here, you'd have a 3, and then you'd have an a times an a times an a. Again, one time we're doing this. I don't want you to do this every time, okay? And then you can see here, I'm multiplying everything, so I can reduce. I can divide by an a, and by a 3, and I can divide by 2 a's. And so I'd be left with just a 7 on top and an a on the bottom. I absolutely want you to do this where you just divide, you take the greatest common factor of 3 and 27 is 3, and you'd be left with a 7. And then here you got a squared and a cubed, and you could take an a squared out of both and be left with an a in the bottom. Okay, I want you to do it that way, but I want you to see that that's what we're doing. Everything is multiplied here. Okay, now as far as the excluded values, I'm only ever seeing, I got a 3a squared and then I got all these a's. There's only one value that a can't be. Can you tell me what a can't be? 0. And that's what you're going to write. Okay, so that's the excluded value part. All right, another one. Number 2, 16d squared over 4d plus 8. Can I cancel the 4 and the 16 and the d and the d squared? Right now, can I cancel that and that? No. Because this plus sign ties the 4d and the 8 together. Right now in this form, I'd have to be able to cancel the entire 4d plus 8. Okay? And I can't do that because I don't have a 4d plus 8 on top. But I could factor the bottom, right? I'm going to leave the 16d squared as it is on top. I'm going to factor the bottom by pulling out a 4, and I'd be left with d plus 2. Okay? It's at this point then you could potentially cancel part of the 4. The 4 I could, pull out a GCF. Or d plus 2, if I could cancel that whole d plus 2. And it looks like all I'm going to be able to cancel is a 4, because I can take a 4 out of the 16, right? 16 is 4 times 4. And so this answer would be 4d squared over d plus 2. Can I cancel those d's? No, because this d and this 2 are tied together. I have to be able to reduce a d plus 2, not just a d. Okay. That, canceling there, is the same as canceling these 2's up here, and that doesn't work. Okay? You got to be able to cancel the whole thing. Back up here at this, if I'd had 2 plus 3 times 2 plus 3, I could reduce that. The 2 plus 3's would work. I could do it then. But I can't just cancel a part of it if it's tied to something else with an addition or subtraction. Okay? And then here, as far as the excluded values, I can tell from here d can't be negative 2, right? What about here? If you set this equal to 0, what would that be? 4d plus 8 equals 0. What would that equal? D can't be what? Negative 2. Same value, right? Okay, so this is my answer. All right, number 3. 2n minus 3 over 6n minus 9. 2n minus 3 over 6n minus 9. Can I cancel the n's there and the 2 and the 6? No. Okay, because this 2n and this minus 3 are tied together. Got to cancel the whole thing, and I can't do that. But we can factor the bottom, right? So I'm going to leave the top as 2n minus 3. Pull out a GCF of what? 3. And I'd be left with 2n minus 3. This is the point where I can reduce. Now again, when I'm canceling, what I'm doing here, you guys, is I'm dividing. I've taken 2n minus 3 and I'm dividing it by 2n minus 3, so what's left? 1. Yeah, not 0. There's a 1 on top, and you don't just have a floating 3 in the denominator, right? It's 1/3. That's the answer. Now there's only one value that n can't be, and it's probably easiest to see right here. What is it? What would make this be 0? 3/2. Yeah, it ends up being the opposite of this divided by that, right? If you have 2n minus 3 and you set it equal to 0, you'd add the 3 over, so that makes it the opposite, and then you end up dividing by the 2, right? Seen that pattern? So it can't be 3/2. So this would be your answer, 1/3, and the excluded value would be 3/2. Any questions? Okay, number 4. 2x minus 8 over x squared minus 2x minus 8. Okay, look at, I got a 2x minus 8. Can I cancel that? This 2x minus 8 and this 2x minus 8? No, because in this case you got another minus here. All three of these are tied together. I'd have to be able to cancel that entire denominator to be able to do that. I cannot cancel these individually. I can't cancel that 8 either. Okay, instead factor. All right, Lauren, can you help me? Lauren D, how would you cancel factor the top?
You take out a GCF of 2.
And what would be left?
You would get x minus 4.
Okay, and then the bottom we can factor, right? This has to be x and x. 2 factors of -8, they give you -2. You got it, Mary? What?
Plus 2 minus 4.
Plus or minus?
Plus 3 minus 4.
Plus 2 minus 4. Do you guys agree? Would that do it? Yeah. Okay, and then now can we reduce? This is where we can reduce, right? We're canceling this entire part that's tied together, the x minus 4, x minus 4. I have 2 over x plus 2. Can I cancel those 2's? Don't do it. No, it's not legal. Okay? It's got to be x plus 2 you got to cancel. Okay, now let's state our excluded values. Any value that at any point causes the denominator to be 0. And it's easiest to see it right here in the factored form, right? Both -2 and +4 would be excluded. Okay? So you look at any point. If you factor the denominator, that's the easiest place to see it. Okay, one more of these. A squared minus 3a plus 2 over 3a minus 3. Okay, as much as you may want to cancel those 3a's, don't do it. Okay, you're going to get the wrong answer if you do. Instead, factor. Can anybody factor the top for me? I heard it. Say it again. Okay, a minus 2, a minus 1. And then can we factor the bottom? How? Okay, so see the common factor that we can cancel here? It's the a minus 1. That's what we can reduce. We'd be left with a minus 2 on top and 3 on the bottom. And there's only one excluded value, and that is 1. We don't have to worry about 2, right? You can have 0 in the top. You just can't divide by 0. Okay, number 2, multiply. So again, reviewing back to multiplying, basic multiplying, if I had 3/5 and I multiplied it by, say, 10/3, when you multiply fractions, you can just multiply the top, right, straight across, and you can multiply the bottom. It doesn't work that way with addition and subtraction, but with multiplication it does. And so you could multiply this out and make it 30 over 15 and then reduce it from there. I'm going to suggest that we not multiply it out, because it's actually easier if you keep it this way, leave it as 3 times 10, and leave it as 5 times 3, that's all multiplied, right? Every part of that is multiplied. So any common factor that's up in the numerator and down the denominator, I can cancel. Like I can reduce that 3 right off. And then a 5 goes into 10 how many times? You can reduce this as well, leaving 2. This answer is 2. If you don't multiply it out, the numbers don't get quite so big. Now 30 over 15, that's not hard. But some of the bigger values, and you really don't want to multiply out if it's all nicely factored. You don't want to FOIL that out. Okay? So if it's just multiplying, I actually could have just reduced right here as well, because this is all multiplying. It's as though it was factored. It's kind of sort of factored, not completely factored, but you can do it right from the beginning. All right, so here we go. Find the product, and again, for the product, we're going to state excluded values. Okay, so same directions here. I'm going to go on to number 6. Find the product and state any excluded values. So 5 over x times 4 over x squared. They're going to start kind of easy. Can't even really reduce anything here. There's no common factors, right? So just do the straight multiplication. You'd have a 20 on top. You'd have an x cubed on the bottom. And tell me what x can't be. What can it not be? 0. Yeah. So that would be your answer. Pretty simple. Yeah. Okay, what about this one? X over x minus 2 times x plus 1 over x minus 3. Is there anything right now that I can reduce? Can I cancel that x with anything? This x right here, can I cancel them with either of these x's? No. Okay. For this one, you guys, honestly, leave it like this. Just leave it all factored. There is no rule that says simplified is x squared plus x over whatever the denominator, x squared minus 5x plus 6, or, you know, that's that, or whether it's factored. Neither one is considered simplified. So I say, why risk making a mistake? Let's just leave it like that. Okay, now give me the excluded values. There's 2 of them, 2 and 3, right? Doesn't matter. 0 and negative 1 don't matter. It's just the denominator. All right. Number 8, 3x squared over x plus 2 times x squared plus 3x plus 2 over x. Anything right off the bat that we could cancel? Can I reduce the x in the denominator? Yeah, with which one? The 3x squared. Yeah, I can automatically reduce that. So let's do that. And then I'm looking to see now, I do need to factor this to see if maybe there's some common factors here. So I'm going to leave this 3 over x plus 2 like it is, and I'm going to factor this, and it does, right? What's it factor into?
X plus 1, x plus 2.
Yeah. And when we reduce this, theoretically it's over 1. You don't really have to put that, right? We don't have to have that, but maybe it's helpful in seeing that this is up in the numerator. Now I can reduce the x plus 2. Should I distribute the 3? You know, you can. Why risk making a multiplication error? Let's just leave it like that. This is simplified as much as 3x plus 3 is simplified. Yeah.
How come you got rid of the other x, the 3x?
Oh, I shouldn't have. Good catch. I needed a 3x. Thank you. Good. Okay, yeah, there should have been an x there. Anything that x can't be? It can't be negative 2. There's another value. 0, right? This one that we canceled here, that one also. Yeah. Again, if you want to distribute, you can. I say why. Okay, one more of these. Number 9, 2x minus 14 over 4x minus 6 times 6x squared minus 13x plus 6. Anything right off the bat that we can cancel? Where is this 6x squared minus 13x plus 6? Where is it? It's up in the numerator, right? Really, it's what's understood to be down below it. A 1. And you can put that there if you want. Okay, nothing can reduce right now, so let's factor. 2x minus 14, pull out a 2, right? Have x minus 7. In the denominator, also pull out a 2. And I'm guessing, just because of what we're doing here, that this can factor a little trickier. 6x squared minus 13x plus 6. 13's kind of big. Kind of. I guess not really. You got it, PJ? What is it? 6x minus 6 and then x minus 1. So that would give me a minus 6x, a minus 6x. That would give me minus 12x. Emily?
3x minus 2, 2x minus 3.
3x minus 2, 2x minus 3. That would give me a minus 4x and a minus 9x. That would be negative 13x. Positive 6x squared, positive 6. Yeah. Is that what you had, Maddie?
I had 6x minus 1 and then x minus
6x minus 1 and then x minus 6. That would give me the outers. It would give me a negative x and a negative 36x. Yeah, I almost made that mistake too, thinking doing 6 plus 6 rather than 6 times 6. Yeah. So I think it's the one that Emily came up with, so this one right here. So we can reduce the 2x minus 3's, right? We also can reduce the 2. So it looks like everything in the denominator cancels away. Sorry, this got a little messy because I was writing out everything. And I think we're left with x minus 7 and 3x minus 2. Would you guys agree? Did I mess something up? Okay, we good. Okay, and then what are my excluded values? 3 over 2. Look at the factored form, right? Right here, 3 over 2. Sorry, these guys I'm going to cancel away. Those were not part of it. Any questions? All right, we're going to go to division then. Once you get to the divide, I'm pretty sure they no longer ask you to do the excluded values. Okay, so we won't worry about it. We're not going to worry about excluded values anymore. We're just going to do the division. Okay, so again, reviewing really, really basic division. How did you divide fractions or rational expressions? What did you do? Multiply by the reciprocal, right? You kept the first term the same. I heard somebody first period say, keep the first term the same and flip the second one over, right? So you do the reciprocal of the second term, and at this point then you could reduce. I would do that. Just reduce and get an answer of 2. Okay? All right, so we're going to do the same. Oh, what if it was written this way? Same thing, right? Take this denominator and multiply by the reciprocal. Wow. And you'll get the same answer. Okay. So example number 10. Find the quotient, all right? And we won't worry about excluded values. X squared minus 25 over 4x plus 28 divided by x minus 5 over x squared plus 9x plus 14, okay? So the first part's going to stay the same. It's only the second one that we're going to flip over, right? So we're going to take this guy and flip him over. Okay, can we go ahead and factor at the same time? Can we do that? What's x squared minus 25 factor into? And then the denominator? GCF of 4, right? Okay, x plus 7. And then I'm going to flip this, so I'm actually going to factor the denominator on top. What does x squared plus 9x plus 14 factor into? X plus 7, x plus 2, and then the x minus 5 we don't need to factor, right? It already is. All right, see any common factors? I think these are kind of fun. They're like little puzzles. Cancel the x minus 5, cancel the x plus 7. So I'd have x plus 5 times x plus 2 all over 4. That would be my answer. We're not worrying about excluded values. Okay. Next one, 4k plus 8 over 6k minus 10 over k squared plus 6k plus 8 over 9k minus 15, sorry. We got 51. Okay. So same idea, right? Which one are we flipping over? The bottom, right? So you're going to take this and... Okay, so can we go ahead and factor also the top? We can pull out a 4. We'd have k plus 2. Here we'd pull out a 2. Have 3k minus 5. And then I'm going to multiply by... Now 9k minus 15 will go on top, right? What can how can I factor that? Pull out a 3. And I'd have 3k minus 5. And then I need to factor k squared plus 6k plus 8. You got a k, 2 factors of 8, they give you 6. Okay, so k plus 4, k plus 2. Okay, so what can we reduce? 3k minus 5, the k plus 2. Anything else? 4 and 2, right? Okay, and that's just kind of keeping everything straight. So I'd have a 2. Oh, 2 times the 3. I should have had 6. I'm going to rewrite that. 6 over k plus 4 would be the answer.
Is there a reason why we don't exclude anything?
You know, these just start getting so complicated to go back and write all the excluded values.
On vision?
Yeah, just the more complicated we get, we just don't continue to practice that skill. But yeah, no, theoretically, especially what you would want to end up excluding is anything that originally caused the denominator to be 0, but you've got multiple, this denominator, these denominators, all of them you'd have to exclude. So it just gets to be a little bit too much. All right, one more, you guys, and we're done. 1 over x minus 2 over x plus 3 over x squared minus 4. Okay, so we're going to flip the bottom. I'm going to have the 1 over x minus 2. I'm going to go ahead and write it this time because it's not that hard. Right? Flip the denominator and multiply. And then why don't we factor the x squared minus 4 just right above it? What's that factor into? X minus 2x plus 2. Okay, and so obviously what can reduce? The x minus 2, so you'd have an x plus 2 on top and an x plus 3 on the bottom. And you would have it.